Okay, good afternoon. Hope you read that. It's going to be important. Three. Okay, we're talking about SQL injection today in Comp 620 and Comp 422. Comp 422 got lost there. All right. There's a new assignment out there. Yes, it's due about 2 weeks from yesterday. So you have plenty of time to do it. It'll cover the material we're talking about today in class and next week in class. It also requires you to install some software. Yes, and well, we'll get to that. The number-based conversion quiz was due at noon today. A whole bunch of people got 100 on it. 50% of the students who took the quiz got 100 on it. 11% of the students didn't take the quiz at all, and they got a 0. The average score was 87, which is not bad. That's an A. 2 students earned a negative score. Yes, they didn't get the memo or something. Remember, it's the percent right minus the number of seconds out over 180. Some people never did it in less than 180 seconds. I don't think they tried. Well, some people tried once. You get to try as often as you want. Sorry. Just be a nice guy. If you didn't do it, you got a 0. If you get a negative score, I upped it to 15 points, which is denotes that you didn't get a 0. Okay. So that was the quiz. Again, new assignments out of Blackboard, due in a couple weeks. SQL, Structured Query Language. Several of you know it. I was on the introductory quiz. It is a declarative language for those who take the programming languages course. It's a declarative language for managing relational databases. It's been out there for a while, developed in 1970 by Edgar Codd. And yes, it's been very popular. A lot of systems use it. It's one of the nice things is you can use it with a remote system. In other words, the database can be on another computer, and it works almost transparently to you. If you're writing a program that's accessing a database on your computer, it's almost the same as if you're accessing a database on another computer. It handles all that for you. And basically, it works with tables. Just think of a table like an SQL spreadsheet or something. You have a table, you've got columns of different information, you have rows representing different data. And then you can access that table. You can add rows to it. You can change values. Do all sorts of things with it. So, real quick review. Now, this is not a database class. I'm just going to go over some of this stuff. So those of you who've never seen SQL before in your life, will have a rough idea of how it works. Okay, there's a select statement. Select statement displays something. If you're doing this on an interactive SQL system and you type in select, then you see this. It would display the information. If you do it in a program, same thing, you select columns and it returns an array of that data. So you can say, I want columns. And again, columns would be things like first name, last name, the column names, name of the table, where we're going to get this data, or star. If you select star, that means give me everything. Give me all the columns for all the rows that meet. So select star from the table says, give me all the rows. You can, of course, just give me this particular column there. Then you can have where conditions with certain things are true. Talk about that shortly. Here is an example. You can say select first name, last name from grades, where grade equals A. And here we go down this table. Mary Johnson has the A, so that we get, or you can say select everything where the last name is Smith, and it will tell you all the information in the order in which the columns are defined in the table. And there you have it. There's more. You could insert rows. You can select, of course, is how you get the data out. That's kind of a reading. Insert is putting data into it. Insert rows, the tables, values. By the way, the blue is keywords, values, and then parentheses, value 1, value 2. They have to be in order. In other words, if the table's first name, last name, ID, grade, then if you're going to insert that, it has to be first name, last name, ID, grade. If you don't want to do it that way, you can always say insert a table or column. Column one would be the name, like last name equals Williams, first name equals Ken, something like that. So you can insert rows. You can also update rows. You can say change, update this table and set this column to this value where something is true, or you can set it to all of them. You can delete rows from the table and say delete these rows where condition. We'll get to conditions in just a minute. And you can join. Join, say take this table, take that table, match them together. What are these? We're not going to talk about that. Joins are a big database thing. And then there are several functions. You can count star that says select, of course, is the read. You don't want to know how you do not want to know what the values are. You just want to know how many are there. Select the count. Give me the count of them from this table test. So tell me how many rows there are. There are more things. Instead of just saying where, you can kind of say like, and then there's a pattern matching where it kind of it sort of matches in there. And other keywords. Is null means that value is not there. There are also other things you can do. Metadata tables, that's tables about the tables. And there are, SQL uses SQL to manage itself. There is a table that has all the tables that you have. And so you can access those. When I think about the Bell-LaPoota model, which hurt a lot of people on the exam, think about it with databases. It makes more sense to me when I think about it, Bell-LaPoota, as using it with a database. Imagine all the tables have a level and a category, or categories, as you will. And people, of course, have levels and categories. People can be secret. The table could be top secret. It could be top secret nuclear weapons, and the person could be secret agriculture or something. So you can select is a read. Select means I want to go get the information. So that would be a read. So you can read from that table. And then write would be insert into the table, set this column equal to that one. That makes a lot more sense because now you can put something into a database that you cannot read. You don't know, but if you knew like the format or the names of the columns, you could insert a row into it. So that makes a little bit of sense. So there's the Bell-LaPoota model in a database. Makes more sense to use it with general files because I'm not exactly sure how you write a file in Bell-LaPoota that you can't read. You could create a file. It's easy. Anyway, we'll hopefully not do that again. Okay, SQL, very commonly used for databases. There are other non-SQL databases. And senior projects, occasionally you find seniors who want to use non-SQL databases. And when they told me that, I knew right away that that student must have gotten a bad grade in the database course. They didn't understand SQL. SQL handles tables. If you have non-tabular information, then non-SQL databases might work. The biggest example would be Google. It's looking at documents. It's not looking at tables. It's looking at web pages and stuff, and it goes to the web pages and finds words. That Google is a non-SQL database. It goes out there and searches non-structured data. SQL uses structured data, tables, 2D tables, rows, columns. That's what it is. And so you can go out there and you can submit. A query is a request to the database saying, I want to get some information. I can select this where that is true. And again, as I mentioned, you can do it on the same computer or you can have the SQL database someplace else. This is important because a lot of systems use SQL databases to keep track of their user IDs and passwords. Your general web application typically has a web page in HTML and uses JavaScript. Doesn't have to use JavaScript, but that's the most commonly used scripting language for web pages. And then it runs a program on the server. PHP is a computer programming language, scripting language again, that is often run on servers to handle web applications. So your JavaScript will send data to the server where the PHP program will look at it and do something. The PHP program often will access SQL databases. If you have information, if it's a sales website, then it sends the request off to the PHP program, which looks up the sales information in the database. Importance to this class is a lot of systems put their user IDs and passwords out in an SQL database. And the first thing the user does when they sign in is enter their user ID and password. And it goes out to the database to see if that user ID is there with the correct password. That is where a lot of security problems occur. Okay, so I don't expect you to know PHP or SQL or JavaScript, but you're going to understand some basics here. All right, here is part of a PHP program that's going to handle entering your name. So you have like enter your name. By the way, I cut this out of the program that returns the score for your quiz that you just did. They're one of the number-based conversions. You can always find out how you did. I sent an email on that. Okay, so all PHP variable names start with a $sign. So $name is a variable equals, and then HTTP underscore post underscore variables dash name says it's going to get the information sent from the website that was tagged with the label name. And you can guess that this probably has label name. And so it's going to send it off to the PHP program. This program is going to get that data that was sent with the variable name and put it into the, or sent with the tag name and put it into the variable name. So at this point, name has whatever you typed in here. Again, without doing anything to it. All the characters you typed in there are transferred to the variable name. And then we're going to generate a SQL query. And we take this string, which is select star from results, where name equals, put the name in that as concatenate. In PHP, the period is the concatenation operator. As I mentioned, PHP is often done with JavaScript. And if you've done this a lot, JavaScript uses the plus for concatenation and PHP uses the period for concatenation. And if you're jumping back and forth between them as you're developing an application, it's really easy to mess that up. But okay, it uses the period for concatenation. PHP allows two different types of quotes, the double quote and the single quote. The single quote, like an apostrophe. You can define a character string by starting it with either one of those two characters. But if you start it with a double quote, then it has to be ended with a double quote. A single quote that appears in there is simply another character. Likewise, if you start a character string with a single quote, then it must end with a single quote, and any occurrence of the double quote character is just another character. So when you look at this, select star from results where name equals quote, single quote, and then this double quote, which matches that, concatenate name there. So it's going to put the name in there, which will be surrounded by single quotes in the query string. And then you go here and you say, submit that query to the database, and here's the result. Okay. An example. All right, here is your standard login for entering your user ID and password and seeing if it's correct. So we get the name, we get the password from the website that was sent. When you click submit, it sends this data off to the server with those little tags and it picks up that data. Then you go select star. That means give me everything from login. We're assuming login is the table holding the login information, where the username equals quote, the username quote, and password equals quote, the password quote. Ending in a the semicolon should be inside the quotes. Oh, well. Yes, SQL typically ends in a semicolon, although most systems are forgiving if you skip the semicolon. Okay, so we generate a string, and then we do the result. Put that query out there. It gives you the result. You go, well, count the number, how many rows will return. If it's greater than 0, Well, we must have found a user ID in it. We're not going to try to match the user ID and password. We're going to have SQL do that. We're going to give it the username and the password and see if it finds a record with that user ID and that password. So we could alternatively look for the user ID and then see if the password that it returns equals the password that we got. We decided to let SQL do all of it. And then if we got something back, we must log. And so here's example query. So select star, give me everything from login where username equals quote can W and password equals quote secret. And again, the quotes are in there because we put the quotes in the character string. Good enough. Pretty simple. Login. Yeah, it's messy. You see here, there's a single quote and then a double quote. These two double quotes match up. They are the beginning and end of the string. The single quote is just a character. It's just a character in that string. It's necessary because when we put it all together, data values have to be surrounded by single quotes in an SQL query. Oh, I didn't say that. Yeah. Okay. Yes. For constants, if you put a constant like a word or something, it has to be surrounded by quotes, unless it's a number. Numbers are inherently constants, and so it doesn't need quotes around numbers. But if you have, like in this case, I should have mentioned that. Yes. Well, depends what kind of score you got on a database. But yes, names, constants, values have to be surrounded by quotes. So you see the quotes in there. Yes, good point. I missed that. All right. Does that answer all those questions? Now, here comes the problem. So we have our standard query here, where, just like I said, for the quotes. Some of the quotes are in the wrong place there, but don't. Okay, so instead of typing in the password, the person cleverly types in this character string here, which is X quote space or space quote A quote equals quote A, nothing at the end, no clue. All right, so you put that into, so the username, whatever the user was, just say it's Alice. I didn't show the username, but the password here, where it was going to be the enter password, ends up being quote X, well, the password equals quote X, quote, or quote A equals quote A. Well, quote A equals quote A is obviously true. A equals A, yes, that is correct. It's always correct. And if you remember the logical OR, a logical OR is true if either side is true. Well, the A equals A is true. It doesn't matter if the password equals X. This is going to be true. And so the select statement is always going to return something if there's a user ID Alice. So it's always going to return a record, regardless of whether the password is correct. That allows somebody to log in without knowing the password by entering this sort of statement. Yes, you are correct. The X could be anything because it's not going to look at that when it all generates its password equals X. That doesn't matter because the OR statement is the other side is going to be true. We assume we don't know the password, or else we wouldn't be doing this. Okay. Now, gets even nastier. You can have multiple SQL statements in a line separated by a semicolon. In some SQL systems, there are several. The most popular SQL system out there is MySQL. MySQL is pretty popular because it's free. Free is a nice price, and a lot of people use it. It works real well. And so you can get that. There are also other commercial databases. Oracle is a major producer of database software. Oracle also manages MySQL. Seems to be a conflict of interest to me, but they seem to do it all right. So MySQL does not allow you to put more than one line on a database query, but generally you can. Other databases allow a semicolon. So let's look at this. Instead of just typing in your password, you type in X, which could be anything, semicolon. Insert into login, set username equals me, password equals my secret. No closing quote. There's no closing quote because the query provides the closing quote. In other words, there's no beginning quote here. In a SQL injection, you have to have an even number of quotes, single quotes, because you're counting on the fact that there's an even number in the query, and you're going to, this accounts for the ending one, and that accounts for the start of the new ending one. So user ID is insert login. We combine that with this, where the password is replaced by this mess here, and it comes out to be select star from login, or we have count, where user ID equals Alice and password equals X, insert into login, username me, and now you've inserted a new user ID into the system. You've inserted user ID me with the password that nobody else knew. Yes, you have a question? Alice, oh, Alice wasn't shown. I just showed setting the password. I could have said setting the password to this and username to Alice. Yeah, that wasn't important, so I didn't show it, but yes, we'll assume the username is Alice. It could be whatever they entered as the username. But now you've not only have you logged in, but you put a back door in the system. You have now created your own user ID and password that you know about. I don't know why you're supposed to get into this system, but now you've got backdoor access. And if that wasn't evil enough, look at this one. Same sort of system where we're doing star, where we go X quote update login set password equals my secret where username equals admin, assuming there's a user ID. Now, this doesn't work if there isn't a user, but we're just going to take the wild guess that user ID admin represents the administrator for the system. And now you've changed the administrator's password. You know the administrator password, but they don't. So if you're going to wreak havoc on their system, it's probably easy to do because now you know the administrator password, and they have a hard time stopping you because their administrator can no longer log in. So, I told you we can be really nasty with this stuff. And of course, remember, I'm telling you about this because then we're going to talk to you about how to prevent it. Because this is obviously, you're not supposed to take this course to learn to be a good hacker, even though you probably are. All right, so everybody see how that's done? Again, this is in a system that allows you to separate multiple commands with a semicolon. MySQL is not one of them. Comments. Everybody knows about / and / but those don't work in SQL. SQL uses 2 dashes, 2 minus signs, and everything after the 2 minus signs is a comment, which is helpful if you're doing this. Remember that everything ends in a semicolon. So let's just do the usual select star from my table where user ID equals and password equals that. And the attacker enters for the username, they'll enter whatever, which doesn't matter, quote, or 1 equals 1. Note the numbers don't need quotes around them. Semicolon dash dash. That's a comment. So we end up with select star from my table where user equals whatever, unimportant, or 1 equals 1. 1 always equals 1. That's always true. Don't need the quotes. And then a semicolon ends the SQL statement. Dash dash says we're starting a quote, and all this stuff over here is just a comment, which SQL will gladly ignore. Everybody understand that? And we're using the double dashes to end a statement in SQL injection, so we add things. Okay, good enough for that? All right, let's give this a try. I'm sad to report to the folks online that I couldn't put this into Zoom. Turns out that apostrophe, see that little apostrophe there? That really weirds out Zoom on poll answers. I put those out there and it just said no. It goes in the never, never land when you do that. And so there's some experimentation. I reported it as a bug to Zoom, but it didn't work for today. So it's one of those things in life. We're working on this. Nothing ever works right. Okay. Anybody need a clicker card? I've got nice, clean plastic, brand new clicker cards from Amazon. Folks online, think about it. I apologize. Okay. Okay, let's see the answers. Right. All right. C was a very popular answer. Uh, actually, the answer is B. B. There are also a lot of people voting for B. B is the correct answer. B is the answer because we're going to put in the password. Oh, yes, what password? So if we enter B, we put B, and it's a quote, and then we say drop table login dash dash. There probably should be a quote after that one now that I think about it. Yeah, I would it more likely to work if you put a single quote at the end of any of these. Okay. And again, the goal was to delete the login table, so this isn't going to do it. C almost, but you have the or. You don't want or. You want to do both of them with semicolon. And just drop login table is going to be used. It's end up that to be your password. Okay, everybody see why C is the answer to, or B, excuse me, B is the answer to this. Okay, those are nice quiz questions. Yes, there is a quiz out there. Yes, there's a quiz I posted on Blackboard. You have to go out to the Comp 422, Comp 620.online. There's a web page that asks you to log in. You put your username, your user ID, that's your A&T University ID, that's your user ID, and then it wants a password. I'm not telling you what the password is. You're just gonna have to log in without it. So you might have figured that out by now how to do that. So, okay. Now, why does this work? Well, it's not exactly a weakness of SQL. One of the awesome problems is a lot of people run their SQL servers with administrative privileges. They run it as root, they run it so it can do everything. Or when you open SQL in your program, you have to give it a user ID and password, and they usually give it root, or sometimes give it root. You shouldn't. No, you should always give it a user ID, password meant just for that purpose. You should have a user ID for this application to access the database and give it the minimal privileges that it requires. Again, back to that principle of least privilege, where you give the users and the programs only the least amount of privilege that they need. If they're going to read this table, they need to have read access to that table. If they're not going to update it, don't give them update privilege to that table. It's not really a weakness of the database or PHP or Apache. Apache is a very common server system. It's basically because people are putting untrusted data where it will be interpreted. You should never execute user input. That's a basic problem. Don't ever allow user input to be executed. That problem occurs in many places. You'll be seeing it in the next couple of weeks, where there are several flaws, security problems, because eventually somebody executes user data, and the user, if they were clever, could have put in something that actually executes instead of just displays, and horrible things can happen. Example here, this was a couple of years ago. It's getting to be quite a few years ago, but yes, that SQL injection attack, they just stole a whole bunch of stuff. SQL injections were very common. People are getting smarter now in preventing them. Here's one that I do want to know. Think about this for a minute. I do have this had no quotes in it, so I could do this one. Oh, rat on the database structure. Oh, great. All right. Okay. Depends whether you're in class. In class, everybody out there going to do that? Okay. In class, there were 6 B's and 3 A's and a couple C's, or a couple C's here. But majority, there are lots of A's. Lots of A's and lots. So it's kind of split when you combine in class and online. That, yeah. Well, your instructors need to be trained. I have gone out there and talked to at least talked to the person who's teaching the database class this semester here at A&T and told him, don't do it. And he promised me he never would. So yes, I know in the past they were doing it that way. Yes, you don't have to do it that way. There are better ways to do it than concatenating strings together. Okay. We talked about earlier that you really don't want to put the user ID and the password in the database. You want to put a hash to the password. You can do a SHA-1 or SHA-256 or whatever hash you happen to like. Take the hash and store that in the database. And then when a password comes in, you get it, you hash it, and then compare the hash that you created from the password that you received with the hashes in the database. If the two hashes match, then the password's matched. The advantage there is that even if somebody happens to get hold of all the passwords in the database, they don't know what passwords will work. You know, as they get the hashes. But because it's a one-way hash, just because you have the hash, you don't know what values you can enter that will create a hash of that and let you log in. So most people figured out now you should store the hash and not the password itself. When you're doing this, there are a bunch of places attack your mind. A user sends data across the network, which is a vulnerability, into the application, which could have vulnerabilities, and accesses the database. So there's many places where problems could occur. As I mentioned, you want to use the principle of least privilege, which I've talked about before, the user ID that the application runs under. And when you access a SQL database from a program, you have to tell it little things like, what database do I want? What's my user ID and what's my password? And you should have a user ID for that application. Just don't use a general person's user ID. Create a user ID for that specific purpose of running that application, giving it only the privileges that it needs. Also in SQL, you can specify users. You can enter users into the database. You can specify what privileges they have. There's all sorts of neat things they probably didn't tell you in SQL databases. There's things called a view. You can create a view of a database which shows to the user only certain restricted rows and columns that you want them to see. So they don't see the whole thing, they just see the parts that you want them to see. Okay. Of course, in order to do that, that SQL injection stuff, not the easy stuff like just logging in without a password. Some of it, you need to know the columns. Well, you can, the column names, you can guess the column names. So if you want to go out there and you enter a SQL injection that says something, blah, 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 and email is null, assuming the rest of it is correct, and you enter it with, and email is null. Well, if email exists, you'll get one error. If email doesn't exist, you'll get a different error. So you look at the errors that you're getting, and you can start trying. Does email work? How about email underscore address? How about email address without the underscore? Start trying a lot of them, and you can figure out what are the names of the columns in the database. You can also guess table names. Okay, if you want to know what to do, you can go users.eu, login, result, figure out, go through the people tend to use the obvious names because in the system where they're working, they want everybody working on that system to understand that login is the place where the login information is stored. You don't necessarily want to give it this long random string because nobody will know what that is, although you can. One of the, as we'll talk about later, one of the ways to hide things or to keep things secure is sometimes to hide the names of tables. Just take names in base 64, encode them or something, and put them out there, and they're weird names and nobody know what they mean. Okay, so you can again, now you might have to sit there for a while and do a lot of these queries. But if you made a program that submitted this stuff to the website, it could probably go through an awful lot. You could give it a long list of potential names, and they could keep trying them until it got an answer that was different and try these others. And you can guess at all sorts of other things. So yes, you can do that automatically. So go out there and figure out the table names, go out there and figure out the column names. Okay, what do you do to prevent all this problem? Well, one of the keys is checking the input. Look for invalid characters in the input. A single quote isn't probably going to work real well. You don't want to have special characters in the names. Now, you might have special characters in the passwords. Sometimes they'll allow certain special characters in the password. Often, single quotes is not one of them. Equal signs is often not one of them. So you can look for, you can try pattern matching as you read the input. It's often, again, better to use what they call whitelisting than blacklisting. Whitelisting is I'm going to look for all the characters and see if they're listed as good characters, as opposed to going through and see if they're bad characters. It's easier to make a list of the good characters. So if something comes in and you look at all the characters and is this a good character? Yes, I'll use it. If it's not a good character, nope, throw it out. And you can either just concatenate it out or just flag the whole thing as poor, as incorrect. There is an existing library out there that will do this for you. It has 3 returns. 1, this field is okay. 2, this field has a bad character in it. Or 3, this has bad characters in it and it looks like an attack. Whereas they know what SQL attacks look like. And they've looked at this, they say, this is not likely to be an accidental. Sometimes you get weird things. You've got O'Malley or O. Henry signing in, who writes his name O, quote, Henry. No, it doesn't work. I have to tell him not to do that. Also, sometimes you can do escaping. %27 is another means of representing a character that's HTML encoding, and that's a quote. Sometimes you can put the %27 in there, and it'll get through the system. They won't recognize it. Other things will then convert it back to a quote after you check, and you can see it. Also, international websites have other characters. Note that if the database is using numerical fields, then you don't need quotes. A number is recognized immediately by SQL as a constant, so you don't need. So we can say ID equals 23 or 1 equals 1. No quotes on here. So you go ID equals, if it was expecting a number or a password going to be a pin with a number, you can do this, no quotes. So they entered ID of 23 space OR space 1 equals 1. They didn't have to enter any funny characters, and yet it worked. So you need to be able to scan the input. There's even a better way. Okay, so one big clue is to go out there and check for weird characters in the input. There's a better way. You can have parameterized statements in SQL. You should not take the input and concatenate it together to create an SQL statement and then execute that. That has all sorts of potentials for errors. Don't do it. Never do it. Because, again, that's executing user input. You should never execute user input. So try this way. Okay, this is going to new. That's opening the SQL system. Okay, we have select from slogan where name equals question mark and course equals question mark. Question marks a special character in this system because then later on you go prepare this statement and then you go bind and you SS means strings. There's 2 strings. You have strings or integer or float. Again, I don't expect you to know SQL or PHP, but what it's going to happen is it's going to take this first variable and it's going to execute the query with the data from that variable there. It's not going to concatenate the string. It's simply going to execute the query. And when it looks for a name, it's going to take the value that you put in student. When it looks for a course, it's going to take the value you put in class and then execute that statement. So if you put in, something like quote, X quote or blah, blah, well, that's going to become the class that you look for. It just takes that value, whatever strings you have, and uses that as data. There is no potential for SQL injection if somebody's using parameterized statements. So that, of course, is the big answer to solving this problem. There are still lots of sites out there concatenating things together to make SQL statements when you should do this. By the way, this looks pretty simple. That's all. You open it up, pick the string, prepare it, put the parameters in there, and execute it. Obviously, after that, you get the results. But I took out all the error checking. You should always check for error codes. Really, when it goes, when we did the prepare, backing up here, we have the prepare statement. It returns an error code. So cat might have it. So if there's an error code, then you do a bunch of things. Die is an interesting function in PHP. It simply causes the program to quit and sends this error message off to the website. But yes, there should be always, in all your programs, always check the return codes programs. So there's going to be one for the bind, there's going to be one for the execute, there's going to be one for the new SQL. Always check error messages, not only in PHP or SQL, but in any program you write. If it returns an error code, check to make sure you didn't get an error. I have had graduate students turn in programs to me, and they thought it worked perfectly because it never got an error, because they never checked for the errors. It returns all sorts of error codes to them, which their programs never checked. And so they blindly thought that everything was working well. In fact, it wasn't working at all. So make sure in all your programs you always check for error codes. One of my pet peeves. Yes. So bind. Okay. Yeah. Again, I don't really expect you to. The SS means two strings. I'm going to bind two strings in this thing. If you want SI, you'd say a string and an integer. Okay. Yeah, that SS is just right. And so it's looking, there are two question marks, there are two letters. If the number of question marks is not matched to the number of characters you have here, you're going to get an error. That's why you always check for these things. And then, again, the value in student is going to be used for name, but it's not going to concatenate them together. It is going to execute the query, and when the SQL needs to look for a name, it's going to take the value you have in student. Right, so it's just, you're not going to get any, you will not get any SQL injection if you use parameterized statements. The answer, right there. Don't use SQL. And still, I think we saw practically half the people were taught to concatenate the strings together. Yeah, we're going to go out and flog some of our database instructors. Okay. I mentioned it. Secure. Okay, we want to make this secure. In order to keep it secure, to prevent SQL injection, use parameterized statements. Untrust. Also, you want to still check for messy input. That's always a good rule. We'll see later on where bad input untrustworthy input can cause problems. And don't think that parameterized SQL is more difficult. It's not more difficult to use, and in fact, it's more efficient. It runs faster than the other ones, particularly if you're doing multiple, because you only have to bind it once and then you run it multiple times. It works better. Okay. So the rule, never ever execute user data, not in an SQL query, not in other languages. In the next couple of weeks, we'll see more examples of this. Don't do it. Several ways the systems can prevent it. Again, MySQL doesn't allow multiple queries per request. That keeps you from doing the drop tables and stuff. Limit the database privileges. Don't run your database as administrator. Run it as a special user with only the necessary privileges that it needs. Have length limits on input. Don't allow the user to enter really big inputs. If you expect them to enter an 8-character username, don't let them enter more than 8 characters. Have them, send them error messages, tell them something's wrong. Because if they're real, they just typed error. If they're not, you might be catching somebody doing a lengthy attack. And hide error messages. If you're using the Apache SQL server, when you get an Apache web server, the SQL, you can set parameters. One of the parameters, as soon as you get an error, it prints a whole page in your web browser about the error, where it occurred, what type of error it was, what line. It's really nice for figuring out what's going wrong. But if you're in production, you don't want an attacker to have all that information. So turn off all the error messages. There's a parameter that turns on the error message, turns them off, turn them off. So all they get is there's an error. That's all they need to know. Maybe more than they need to know. Okay, another question just to see if you're awake. Okay. All right. Not that hard. You know the answer to this. Okay, there it goes. Take a decision. Okay, we got it. All right, good enough. Oh, okay. Almost everybody thinks it's A's. Good, you're paying attention. Good enough. Yep, okay. The answer, A, almost everybody got that. Good deal. If you didn't get the A, back up and read this again. All right. Blind SQL injection. Again, sometimes you don't get these error messages. You can still do things, attack. It's slower means of attacking, where you can only get like a true or false response. But not to worry, there are tools out there that automate this. You can automate this. You can find out things. You can start guessing user IDs and passwords, starting out, so many characters. And it doesn't take too many guesses, particularly if you have a program that does all this for you. And that's the way to do it. So you can do binary searches and find these things. It doesn't take that long at all. And again, I'll remember here, it takes 10 seconds to make each request. And if you don't make any mistakes, there's an 8-character username. It's just over 10 minutes. So could do more. All right. We'll move on to our next topic here. Reminder that there is another assignment out there. All right. And enough of this. And let's share the screen. Okay, we are back. Hopefully the online people can see this. All right. We want to talk about steganography. Steganography is the science of hiding information. It's hiding messages so you can't find them. I like to talk to this is kind of a fun topic, where how can you hide the information so people can't find. One thing is to encrypt it, so they may be able to see the message, but they can't figure it out without the key. But to hide it, they can't find the message. Now, steganography is kind of security through obscurity. It works because they don't know where the message is. There's Kirchhoff's principle, which is very good. Cryptography systems should be secure if everything about the system, except the key, is public knowledge. And Shannon also said that assume that the enemy knows the system. Talked about it before. If somebody knows the algorithms you're using, the media you're using, but if they don't know the key, they shouldn't be able to get your system. That's not necessarily the way it works with steganography. In steganography, we're just hiding the information. And there are some times where somebody might want to do that. If you're using just encryption, people may know that you're sending a message. They might not know what the message says, but they know that you sent a message. With steganography, they may not know that you actually even sent the message. Steganography has been around for a long time. This guy in 1490, what is it? I'm not sure. Well, okay. I'm not sure about the dates here. And I realize this is 1499, and that's like 107 years later. That might be, maybe I have years, but it's Middle Ages type. Published this book. It's interesting that it looks like it's talking about magic, but if you know the key, it's talking about cryptography and steganography. And it was written way back in. Because, of course, it looks like it was magic, the Catholic Church put it on their Index Laborium Prohibitum, which is a list of books that Catholics were forbidden to read because they were immoral or contrary or heretical. So, yes, so it was thought to be an evil book. That's because apparently they didn't have the key. There's all sorts of ways you can hide messages. People can do it, all sorts of clever ways you can do it physically. Some of the ones I like are get yarn, the piece of yarn, mark it in Morse code, dashes and dots, and then knit it into a sweater or something and give it to your courier who's going to wear it to the other side, and where they'll take it, pull the sweater apart, look at the string, and decode the Morse code. Yeah. And of course, as you wear it, it's just a modeled pattern, you can't tell any, because knitting tends to loop it around. You don't see the spacing inside. So yeah, it kind of looks like a gray. It looks another ancient one, tattoo the message on the head of your courier, where their hair will grow back and cover it. When the courier gets to the other side, they shave his head and read the message. Secret inks. Yeah, what kid hasn't, tried to write something in secret ink? Lemon juice works really well. Then you heat it up and it shows. Or write on upper right-hand corner of the envelope and then cover the message with the stamp. All sorts of ways to do this. Some ways with writing. There's an example, a crazy way where they have tails of letters that swoop up. If it swoops up, that's the end. So you count how many letters until you get a swoop. There's 3 here, 3 there, 5 there. You get a bunch of string of numbers. And then in this case, it's a substitution cipher that you pair up the numbers and you use it. Here they have 25 characters. Remember, there's 26 characters in the alphabet. They just say I's and J's are the same. You can usually tell the difference by context. You can also use U's and V's. In English, for hundreds of years, U's and V's were the same letter until later they decided that maybe they should be the same or be different. Anyway, so you put together. So you got a message here. Arnold, dear, it was good news to hear that you have found a job in Paris. Anna hopes, and it decoded, it says, need money for assassination. Okay. You can use steganography and encryption. In other words, you can encrypt a message and then hide the encrypted message. The advantage there is the other side won't even know that you sent a message, and if they possibly find it, they can't make any sense of it. Now, this can be used for the dark side. You can hide malware. There is a malware, one Lokibot, and others. Lokibot was one I found that hides the code in image files. In other words, in a JPEG or a PNG or something like that, that the code, the malware code, is in the file, hidden in a way that you have to have a program. And often they had a script in a Microsoft Office document that, when executed, would go out to the image and pull out the file and then create the executable and execute it. Another way to You only have to have bits. You could have zeros and ones out there. And if you can hide something that represents a zero or hide something that represents a one, then, or HTML. HTML has things that don't show. You can have comments in HTML. You put usual things slash, whenever you have a comment in an HTML document, it doesn't appear on the screen. It appears in the .html file. It's often comments. If you're writing an HTML document, you might put comments about what you're doing here, particularly if you're in JavaScript. Well, you can put secret messages in the HTML. When it appears on the screen as the document, nobody will see your message. But if they were to look at the source code, if you right-click on a HTML document in your browser, you can click, look at the source, and you can see the comments. There are programs, by the way, that will take out all the comments and everything and make your browser pages hard to read. But also, there are characters that you don't see. Favorites of Unicode characters, 0 with joiner and 0 with non-joiner. I'm not exactly sure why you want these, but they do exist. I went out and checked them. Yes, these are characters out there. Unicode. Remember, Unicode is a 16-bit character code used by Java, I think by Python. The old those of us with gray beards remember ASCII, which is an 8-bit code, maybe a 7-bit code. This is a big one. So you can have all sorts of character sets. You can have English, German, and Chinese, or Japanese, whatever, and all the languages you might want. So there's lots and lots of characters, including a couple of strange characters out there. So you've got, these things do not appear on the screen. They're just characters in there. So you might say a 0 with joiner is a 0, and a 0 with non-joiner is a 1, and then scatter them through the document. They never appear, but if you go and you write a program that scans the document, you can pick them out, convert them back to zeros and ones, and you've got the message. Some file formats allow you to hide things very easily. In PNG, the data is in chunks. By the way, I didn't make that up. That is, in fact, go out and read Wikipedia. It defines them as chunks. The data is in chunks. A chunk has a header. The header gives a type. What type of chunk is this? The length. It has a checksum. So, if you read it and you don't get the proper checksum for that chunk, it's incorrect. Well, if you put a new chunk label in there, it ignores it. This is intentional because it allows programs which display PNG files, if they get a chunk they don't understand, because somebody came out with a new level of PNG, an update to it that added some sort of values that were expected to enhance the display of the information. If they put that out there, well, the old program doesn't want to blow up and not display this, so I'll just ignore that chunk I don't understand. Well, you can make your own chunks and put data out there. I did it. This little migratory bird picture has parts of the syllabus in it. You can't tell it at all because none of that displays. It's hidden in the file. If you look at the file, no, it's a PNG file. If you look at it with Notepad or something, you'll see it, but it doesn't display. It's a swallow carrying a hook in it. All right. Then sometimes you can distort the pictures and get a completely different picture. I like this one. This picture here, trees, is the original. But if you take out all but the last 2 bits of each color, the colors are represented by an 8-bit value. So you take out the upper 2 bits, and then you get a number, and then you increase the luminescence of the how bright it is. You get the cat. You don't see the cat over here at all. You don't see the trees over here. But yes, you can change the picture. Both images are in the file together. Okay, real quick review of graphics files. Almost everything you see is a raster, a bunch of pixels, just little dots representing the color. There are vector systems that draw lines. Long ago and far away, I worked to support, I was in system support of a drafting system, and the great big, physically big drafting screens did raster graphics. And when you draw a line, from here to this diagonal, that diagonal, it drew that line. It was, no matter how much you magnify it, you didn't see any jaggies. If you do a diagonal line, you look at it closely with rasters, you see a bunch of boxes that are jagged. Never happened with the vector system because it doesn't draw. It says, take a point from here and a point there and draw a line between it. And that's what it does. So most things are pixel oriented. The number of pixels you have on the screen depends on the feature. Your monitor and your screen generally has somewhere around 90 pixels per inch. It all depends on the clarity of your monitor. Phones are a little higher because everything is small on a phone. You have to have good eyes. And so they put a lot of pixels out there. The actual number of pixels depends on the resolution, the pixels per inch, and how big it is. Printers, by the way, if you have a printer, they usually print about 600 to 1200 pixels per inch. That's 1200 is, well, 600 is the average because you hardly ever can tell the dots in a pixel. But at 1200 pixels per inch, it's way below what you can see. So that makes a very clear picture. You can go out and print something. You can look at your printer. If you have a printer, check the options. It probably has options of what resolution you can print something in. You can print it in different resolutions. Try it in different resolutions. Doesn't make much of a difference. Now, a pixel is a picture element. It's one dot. The dot is typically represented, it's in color. If you have a monochrome, it's usually only two colors, black and white. Or you can have shades of gray. Bunch of, often 64 shades of gray. Much more than 50. So you could have it out there, and you could take 6 bits to represent shades of gray. But mostly they have colors, colors. And the colors are represented by red, green, blue, RGB. You talk about an RGB number. And there are 3 numbers, usually 1 byte, so it's a number between 0 and 255, because that's the maximum number of values you can fit in a 8-bit number. So it's red, green, blue. And then there's another one that tells you how intense, how dark or light this is. So that gives you the color. How many bits are out there? Well, again, black and white's on 1 bit. If it's a full color, it's 24 bits, 3 times 8 to get, and there's another byte for intensity. Simple graphics. If you're using a tool that's making an image and you're only using red, green, blue, if you only have your kindergarten box of crayons with 8 different colors, then it doesn't need a lot of different bits to represent the colors. You can get by with fewer bits. There are all sorts of formats, BMP, blah, 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 JPEG, GIF, PNG, lots more. BMP is very simple. It's a bit map. That is, there is each pixel is represented. If it's color, then each pixel is represented by 4 bytes. That takes a lot of space because you have 1,000 by 1,000 pixels. That's 1,000,000 pixels. If there's 4 bytes per, that's 4 million bytes to represent the picture. It doesn't compress at all. There's no compression in it. So it doesn't matter how complex it doesn't compress. Whereas this PNG is out there. People might have heard of GIF before. Turns out that GIF has a patent, trademark, some relation. So people stopped using it because the people who own GIF said, "Oh, you're going to use GIF, you have to pay us for it." So people said, "Forget that. We'll make up an alternative." So they made up PNG, and PNG uses lossless compression in it. It stores the information as how it's displayed and compresses it, but not like JPEG. I think we talked about JPEG earlier in the semester. JPEG has different levels of quality, and it compresses, but it's a lossy compression. It compresses it and may lose some information. Not that you ever notice, because generally the loss of image resolution is not within the human eye, but it makes it much smaller without being. So it's lossy compression. PNG does not have lossy compression. It uses these very clever discrete cosine transform. I don't know if you can see this, but if you look at this carefully, there's all sorts of gray dots. JPEG works really well for pictures, for photographs, journalism professional experts group or something is what JPEG stands for. It works really well for photographs, because it takes photographs and compresses them nicely. It does not work well if you have generated images that have characters in them, because the compression it does, the cosine, whatever, these dots. So if you're going to have something that was generated by a computer, use PNG. If it's a photograph or something that looks like a photograph, use JPEG. BMP, of course, doesn't distort anything in any way, but they are large. Okay, you can hide data in the image by modifying the least significant, the rightmost bits of an image, or those pixels, the numbers that represent the pixels. Remember, there's 3 bytes, red, green, blue, for each pixel. If you change the numbers just a bit, just the lowest bit, so that means the number is going to either go up and down by 1. Either if it's an even number and you change the leastmost bit by 1, it's going to go up 1. If it was an odd number and you change that lastmost bit to a 0, it goes down 1. So you don't make a big change in the number. So it's only a very minor change in that color. It's very hard for humans to. Also, if you want to set the bit to a particular value and the bit was already different values, you have a 50-50 chance that the bit was the value you wanted anyway. You can think about it. What was the bit was 0 and 1, the bit you want to set to 0 and 1. And so the 50-50 chance that you didn't make any change at all to store your information in there. The bit just happened to be the right way. So that means it makes no distortion in the picture at all. Here is my example. So we've got the original image and the image. I can see no difference between these two. And I wrote a program that does this. It stores actually the syllabus for the course is stored in here in the leastmost bit of the blue pixel, which is 3 bytes. I didn't change the red and the green. I only changed the blue and put the least significant bit there. Then I got a little bolder, and I said, well, let's do 8 bits. So I changed 2 bits of red, 2 bits of green, 3 bits of, no, 3, 3, and 2. I can't remember how it was split up 3, 3, and 2. So maybe 3 in the red, 3 in the green, and 2 in the blue. And still, I can't see any difference between these two. Let's not do that question. What are the best bits? What's the least significant bits? The rightmost bits, because changing those bits only change the number by, think of a binary number. If you change the rightmost bit, it only changes up and down by 1. If you change the leftmost bits, we change it up by hundreds. That's going to make a big change in the color. If you look at this picture, I know it's very hard to see from where you're standing, but from up here, there is a minor, with the hidden text, there's now kind of dots, there's lines and small lines. It's because this is a very plain, when you have a picture with the dinosaur, what type of dinosaur is that? It's a Stegosaurus, of course. Okay, should have known that one. Yes, okay, well, here with plain colors, it's possibly visible. Now, sometimes you might want to do this. There's legitimate reasons for doing this sort of stuff. Some brands of color printers add tiny dots, giving the serial numbers of the printer plus the date and the time, which is really helpful to the FBI. If you print out a ransom note in your printer and send it to somebody, the FBI will look carefully where they expect to find these little dots that you don't see and go, oh, it's HP 4341 and it's serial number, oh, and who bought that? Yes, so. And then there's digital watermarking. We're not going to talk about watermarking, but it's an interesting topic. Watermarking is displaying, putting information behind it. Sometimes you go out and you'll see in the background of a picture, fade, a light image in the picture, whereas that's a watermark telling you that this picture is owned by somebody. Don't use it. If you go out to Google Maps and you're looking at a photograph that, you go out to Google Maps, you're looking at what they call the satellite view. It's usually taken by airplanes, by the way. The satellite view of the area, there'll be in the background, you'll see it says copyright Google. It's their picture. Okay. And sometimes there are watermarks that you can't see. They do a very clever job of hiding it. Also, what happens if you edit the file? Did you lose the watermarks? Some engineers have found watermarks that can survive certain amounts of editing. And if we're going to talk about steganography, we'll go back to that chafing window we discussed a couple weeks ago. That is a steganography trick by sending a whole bunch of messages where every now and again, some of the messages have a MAC that's good, some of the MACs that's bad. You can't tell where the message is. Steganography. You can put it in other media besides pictures. You can do it in audio recordings. You can hide sounds in there that you can't hear. Put digital clicks and stuff that you can't. My radio can tell me what channel and what song is being played, even though if I listen to that station on an old radio, if I have an old boom box, it doesn't, you can't hear anything, but my car picks up that because there's information hidden in the song that it picks up. So you have hidden information. And of course, things at different frequencies. Oh, videos. Videos just like lots of pictures. You can hide scads of information in a video. Now, stake analysis is looking for this. How do you find this information? It can be very difficult to find. On the other hand, by putting a message in there, you change the probability that a bit is. In other words, if you look at something as a plane, that 4 squares of different colors, you would expect all the bits to be the same. The least significant bits are the same. If you hide something, suddenly the least significant bits change a bit. And they might change in a different pattern. You can detect it. Now, JPEG compresses things. If you store a message in a BMP file and then switch to JPEG, you're not going to see your hidden message anymore. It's gone because JPEG is going to compress it. There are tools out there, an assortment of tools. I went out to Wikipedia. It lists 23 available tools to do this for you. I mean, there's all sorts of tools that are, commercially available. A lot of them are free. I get free tools. I downloaded and tried one. Here's the original picture. Here it is with the syllabus and the least significant bits, and you can't tell any difference. I can't let this picture go. We have a Stegosaurus fighting a T-Rex, I think. Raptor. It should be noted that the Stegosaurus went extinct 70 million years before T-Rexes appeared or raptors appeared in the world. So that never happened. Everybody thinks all the dinosaurs were there. No, the dinosaurs came over millions and millions of years. There were much more time for dinosaurs than there has been since there were no dinosaurs. But that's not what we're talking about today. Okay, what can you do about all this? How can you stop and prevent steganography? Well, content threat removal is basically replace the original message with content. Imagine you have an image or say an image. You aren't sure you can take a screenshot, or say you have text, or a file with text, and you know what's in there. You can take a screenshot of the file and then do character recognition of what's on there. And now you'll have only what appears and you won't have any secret information. There's a bunch of ways you can do the similar things with images. Take the image and again, running it through multiple transformations. If the image is a JPEG, convert it to BMP, do a minor edit on it, convert it back to JPEG, and whatever was there is gone. Okay. That's it for steganography. I just thought it was interesting. Remember, there is an online assignment out there due October 8th. That's 2 weeks from yesterday, 13 days from now. Well, actually, 12 days from now, I guess. Now, we haven't covered everything you need to know for that material. We will cover it on Monday, but some of this is SQL injection. So go out there, give it a shot. As always, do not wait to the last minute. I would not start this at 11:30 Tuesday morning and see how it goes. Okay. All right, that's it. I tried to respond to everybody who emailed me with concerns about their exam. If I didn't respond to your exam, sorry, email me again. I got several emails. Any questions online? Hold on.